and 5. So the first question, which quantity is a physical quantity? Got to be this, because you can count charges. All of them, this is a ratio, this is a ratio, this is a ratio. It's not physical quantity. Which time interval is the shortest? Nano is 10⁻⁹. Pico is 10⁻12. Micro is 10⁻⁻6. Right. So the shortest, I think this should be the shortest, because if I, move everything, I move point here, so it will be 5 into 10⁻⁻1. No, it will be -5. This will be 5 into 10⁻⁻8. This will be 5 into 10⁻⁻7. And this will be 5 into 10⁻⁻7. So this has to be the smallest. Okay. Now it says P and R are coplanar vectors. If X is equal to P minus R, what is the diagram? So we got to make this equation, right? So P is the same. Minus R would be exactly opposite, like this. So the resultant would be from this point to this point, like this. This should be X. P R, wrong. Oh, wait a second. Why would it be wrong? This seems correct. P minus R. So this is P, this is R, but this is minus R. Yes, that is correct. This is not correct. Nope, nope. Stop. All right. Now, if you have any questions, please let me know. Then it goes here, CRO. So it has 1, 2, 3, and 3.5. So 3.5 waves in 10 centimeters. So one wavelength will be 10 divided by 3.5. So this is 2.86 meters. Okay. So now we have the time base. So time period is equal to the time base multiplied by the wavelength. So time base is 5 multiplied by 2.86. Okay, so 5 into 2.86, that is 14.3 milliseconds. So 14.3 times 10 raised to minus 3, 10 raised to minus 2. 1.4 times 10 raised to minus 2 has to be D. Now, the diameter of golf ball is measured calipers and found to be this. The volume is this, where D is the diameter. What is the volume? Okay. First of all, we're going to find the volume. 1 by 6 pi 4.11 cube. Shift. Okay, so I'm getting 36.35. So, all right. And then I will do change in volume over volume equals to change it d over d because there is no other variable, and then multiply by 3 because there is a cube over it. 0.01, and here 36.35. Okay, let's do it. Multiply by 3, multiply by 36.35. So change in volume is 0.26. Now, uncertainty is always one significant figure. So when you take it to one significant, this is 0.3. So this is the correct answer. And the answer you got rounded to correct decimal places. So 36.4. So if you don't remember how it is done, please remember. Uncertainty is always one significant figure, and the answer should be in equal decimal places as answer. So that is the rule, if you don't remember. Okay. Then going to 6, which diagram show the variation of time of the distance traveled by cyclist. So cyclist cycles uphill to a shop, taking 10 minutes. Then spends 5 minutes in the shop. Okay. And cycling downhill twice the initial speed. So first of all, it's a distance time graph. Okay. So it should not be giving us anything like negative values. I mean negative speed. I don't think so. Neither this is correct nor this is correct. So these two could be. If this was displacement, then we would choose A or B. But right now C and D is correct. So if he has, you need to remember speed or velocity is the gradient. So if his speed was less before, his gradient should be more. Gradient is less, yes. This is correct. This is correct. This is correct. Higher gradient means greater speed. So that means this is twice the initial speed. That's why. Acha, uske baad he says two cars X and Y traveling along the straight line. Car X has a constant speed, car Y has a constant acceleration. Okay. Car Y has a constant. At the instance shown, car X is a distance d ahead. Car Y is at speed of 4. Car Y is level with car after time. What is the distance d? Impressive. Now, these sort of questions, well, now, right now they have a distance d in between, right? So for car X, I would say that, yeah. Okay, let's think about it a bit. All right. Car Y. So SUVAT. So car Y basically needs to cover this distance d. So let's call this d. The initial speed was 4. Final, we don't have. Acceleration is constant. Yeah, that is also given. 0.50. And time is not given, right? Car X is constant SVT. Okay, so the distance that car travels is, I have no idea what that would be. Whatever that is, let's think about it. This is 6 and time is not known. Right.
Sir, did you not consider the 20 seconds that they've mentioned in the question?
Where is it? Acha. Yeah, we should that right? So car X and car Y are level with car X in 20 seconds, right? Okay, but there's a difference in speed as well, so there has to be some other thing as well. So I need to cover distance this. Let's say it goes like in 20 seconds, this car travels, say some distance, X. Okay, let's say. So what is that distance? We could say velocity into time. First, we're going to do this. This is not a very simple question, really. 60, 6, 8, 12, 120 meters. So it means it already at this speed, it will travel 120 meter plus this distance d, if this was like starting now, right, in 20 seconds. So I think we should add 120 here as well, because the fact is that it will be ahead 120 and it will be like racing towards it. So it needs to go like that. But let's see if I get the right answer. I don't know. So the best equation to use then would be S equals to UT plus half AT square, D plus 120. That might be wrong. 4 times 20, half, and 20 square. Okay, let's try. Okay, that brings it to 180. And if we subtract 120 from it, it should be 60. Okay, so I don't know, but according to me, it should be 60. Can somebody please confirm the answer? Okay, please check the answer for this question. Okay, let me know. All right, then the graph shows how the quantity P varies with Q. What could be the quantities? Right.
The other one is correct. The answer is for 7th.
Awesome.
Yeah, 16.
Awesome. Who does not understand it? Please let me know. Okay. Because now I do. What could be the identities of P and Q? Let me think. First of all, I want to tell you, this is a straight line graph, so it should basically from origin should depict somewhat like this. A force is equal to ma. So if we keep x on a, if we keep force on y, but this is force of a resistance. That's wrong. A resistance formula is way different actually. It's not the same. A resistance formula is 6 pi r eta v. That's not correct. Okay, no. That's wrong. Kinetic energy. Kinetic energy is half mv square. Kinetic energy and time doesn't make sense to me. Acha, power is equal to energy over time. So kinetic energy equals to power into time. It's talking about power then. But it's saying it is falling for air for a very long time. No, doesn't have to be power at all. Potential energy and height. Yes, it is constant velocity. This is not even changing. So gravitational potential energy is changing with respect to height. So let me check. mgh equals to E. Y equals to mx. E, right. X, right. And this should be, yeah. This is the answer. Work done against work done is not there. It's not right. Now, if this was force versus speed, I could have taken it, but not that. All right. Then it says a rock R of mass is large distance. Okay. 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 Which statement is correct? The change in momentum of S is in the direction of the arrow X. It is like this. It is like this. Right. Well, change in momentum. The change in momentum, the change in velocity of S is approximately 20. Change in velocity. But why? So if I find the change in momentum of R only, or we could say this was stationary, right? It said it was stationary, you know. If this was R was here, right, then it would pull it here. So S will be pulled here, which means that the change in momentum of S in the direction of X is not correct, because it should be in the opposite direction. Chala, that one thing is wrong. Then the change in velocity, let me try. So initially the momentum was 1 point, I'll use M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Let's take this side as positive, this side as negative. So this will be 10 raised to 27 multiplied by 10 raised to 4 plus, this was 0 because it was stationary. Then afterwards, it changed its momentum. So it was 10 raised to 27, but now minus 10 raised to power 4. And this is 10 raised to 30, and we need to find this velocity. Let's try. 10 raised to power 27 multiplied by 10 raised to power 4. Uh-oh. All right. I don't know what that is, but never mind. Minus. No, we got to add it. Add it by 10 raised to power 27 multiplied by 10 raised to power 4. Okay, whatever that is. So, and then we divide it by 10 raised to power 30. It's 20. So final speed is 20. That is correct. B is correct. Magnitude of change in momentum times would never happen. Magnetic momentum does not change. That is wrong. It will always change because it's change in direction. So that's fine. B is correct. If you want to know more about it, please let me know. I mean, if you don't understand anything.
Sir, can
Now,
you explain why it's not A?
why it's not A? Yes,
Yeah.
I'll tell you. If R was here, consider R here, right? So S would pull R where? Towards it, right? So this red force is basically pull of S to R, right? According to Newton's third law, S will be pulled in the opposite direction with the same value. So this will be pull of R on S. Do you understand? So if S was pulled in this direction, how is it that its momentum is changed in X? That's wrong. Its momentum was changed in the other direction, the opposite one. Do you understand?
Yes, sir. I got it.
Now, this is all right. After the impact, they move off together, which means they combine. What is the kinetic energy lost? First, I'll check half. Oh, first we need to see what is happening afterwards. Afterwards, this stick, right, like this. So they will have certain velocity. So let's check. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. This was 2, this was 4. I'm taking this side as positive. This is 4 times 1. 2 plus, now when they combine, right, you just add the masses and they will move off with the same. 4, they move off with the same mass. So this is 8, this is 4, 6. 4 plus 6 is 12, 12 plus 6. So it means velocity was 2 afterwards. Now the next part starts actually. So half mv square, oh sorry, half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. Okay, now this is half 2 4 square, half 4 1 square. In this one, the masses are same combined. So 2 plus 4 and v square. V is 2 by the way. Okay. So on this side, it is going to be 2 and 2 cancel. 16 plus 2 equals to 3 times 4. This is 18, this is 12. 12 and difference 18 is 6 joules. So 10 is 6. Now, this is not there anymore. Skip it. Okay, we could do this. One person, okay, 2 people push a vertical gate to open. What do you mean by vertical gate? Like this or like this? I don't know. All right, let's see. The person standing, a person distance d1 and pushes, okay, all right. The other person distance d, okay, fine. What is the total moment? First of all, we would like to find what is the components of it. The perpendicular component of this force, like F1, is this one. So if you try this, this will be θ1. So this will be F sine θ1. And perpendicular force of this one is gonna be F sine θ2. This is F1, this is F2. Okay. So both of them will turn this way, which means that you got to add them. F1 sine θ1 plus F2 sine θ2, and you got to multiply with their distances. So this means the correct answer would be F1 sine θ1, F2, this one. This is correct, 100%. Now, a ball is rolling down a slope at constant speed. 3 forces acting on ball.
So why can't it be cosine?
Because the force has to be perpendicular to the distance, and the force that is perpendicular is sine. Check this, check the vectors. If I make this vector, if I make this vector, this angle is an alternating angle here. I want this force which is perpendicular. Sine ho gaya na? That's fine. Okay.
Okay.
So it's perpendicular times perpendicular distance times force. Okay, what diagram represents these forces? So if it is going at constant speed, which means that the forces are in equilibrium. Now forces in equilibrium basically must always pass through the same point. So let me tell you why. The weight is going to be down. Then air resistance is going to be here, right? So, and the third force would be the normal reaction, like this. When you combine this, they should just make one loop. If I start from here, this is opposite. That's wrong answer. If I start from here, then go here, then go here. This could be one of my contenders. All right, so I'm gonna check on it. See, here, this is wrong because arrows should go in just one flow. Here. This is correct. So either this is correct or this is correct. Now I have to see what is the major difference between these two. Okay. Okay. If I see the major difference, and that is that here this force is larger, this force is larger, this is smaller. Here, this force, this force, this force are almost equal. And also they perfectly, like this force shows something like this. But it isn't like this. So it has to be D. It just like feels like that. And the forces I've drawn on the diagram has to be correct. This is normal reaction. This is A resistance. Track like that. So I think it should be D, although B is very, very close as well. Now, equilibrium forces always like, in resultant, the diagram that shows resultant is this one. Like you go in one direction, like if this was X, this was Y, you add X and Y, and the resultant is always in the opposite pathway. In a equilibrium, all forces go in a single loop. So you can always, check which is correct. All right, now going here. What is the pressure of gas? What is the pressure of gas from the gas tap? Okay. So first of all, I will see what is the difference in height to find the difference in pressure. Naturally, gas is pushed the liquid above atmospheric pressure. So the equation that I'm looking for is difference in pressure of gas minus pressure of atmosphere, right? Now, so difference in pressure will be density, which is 1000 times 9.81 times the height difference is, I got to find it actually, 31.4. This is 21.2 centimeter evasive. So I got to change it. 21.2 will be 0.212 meters. Now I want to find gas, and the atmospheric pressure is 101 times 10 raised to power 3 pascals. So let's add both together to find it. Let's do it. 1000 multiplied by 9.81, 0.212 plus 101 times 10 raised to power 3. So I get this pressure, 103,079. Let's check what is the answer. 103, that should be 14. D. Please do check this one out as well. Now here it says P is the kinetic energy.
Sir?
Yes.
You just calculated the pressure with the change in gas. Then what did you do?
I found what is the change in pressure.
So did you add the 101 times 10 to the power of 3 or?
Yeah, I added it because
You had.
this is my equation.
Oh, all right.
If the pressure of gas was less, then this would be down, this would be up. And if that is the case, then we get change in pressure to be atmospheric minus gas, like that. So you have to check. For this one, you can see gas has pushed the liquid down more than atmosphere. If the atmosphere pushes the liquid down more than gas, then you use this equation. Do you understand?
No, you had me confused at that part. Could you repeat that?
Yes. This is a tube. So here is atmosphere acting. This is gas, right? If this liquid is down, this level is up. This means that gas pressure is more than atmosphere. right?
Yes.
And if this is gas and this is atmosphere, this is down, this is up. This means atmospheric pressure is greater than gas, right?
Yes.
For this one, you use change in pressure, gas minus atmosphere, because gas is larger. For this one, you use atmosphere minus gas because atmosphere is larger.
All right, sir. Thank you.
Okay, now at P, the kinetic energy of trolley is 5 kilojoules. Between P and Q, the trolley does 10 kilojoules of work. Okay. What is the kinetic energy of trolley at Q? At P. Oh, wow. This is quite, okay, sorry. It also says that it has potential energy 50 kilojoules. Sorry, trolley runs from P to Q along a track. At Q, its potential is 50 kilojoules less than P. So this means that wait a second. Between this level and this level, the difference in gravitational potential energy was 50, and the work it has done is this. So 50 kilojoules is the change, and there is 5 kilojoules of kinetic energy as well at